The moon circles the Earth about once a month as the Earth spins beneath it each day, and together the Earth and moon orbit around the sun once a year. The relative positions of the sun and stars slowly change during the yearly orbit of the Earth-Moon system around the sun, but from our point of view on the surface of the Earth, objects in the sky appear to rise, cross the sky from east to west, and set below the horizon due to the direction the Earth rotates each day. This daily motion is the most noticeable and dominates our perception of the sky. The moon actually orbits the Earth from west to east, so that it slowly appears to be slipping backward relative to the perceived daily motion of the sky as the Earth spins. This causes the moon to rise a bit later each day over the course of about a month, so that it will progress from being on the side of the Earth facing towards the sun to the opposite side facing away and back again. From Earth we can only see part of the portion of the moon illuminated by the sun, depending on where it is positioned in the sky relative to the sun, and this produces the cycle of moon phases. These range from full moon, when we see the entire lit side of the lunar surface on the opposite side of the sky from the sun, all the way to the new moon, when the lit portion is facing completely away from the Earth, and the moon is very close to the sun in the sky. Just before and after the new moon, a thin crescent is visible as only a small amount of the illuminated portion of the moon is at an angle that can be viewed from Earth. As the moon orbits the Earth, more and more of its illuminated surface will be visible over time, seeming to increase from the westward edge of the moon until full, and then disappearing again from the westernmost edge until new. The plane in which the moon orbits the Earth is very similar to the plane in which the Earth orbits the sun. Because the axis about which the Earth spins is tilted relative to this plane, the place where the sun rises and sets, the path it traces in the sky, and its position relative to the stars changes by a small amount each day in a pattern that repeats over the course of a year. The moon seems to follow this same pattern over the course of about a month. Although the moon is much closer to the Earth than the sun, and it orbits the Earth instead of the other way around, from the surface of the Earth, the patterns of their motion in the sky appear to operate in much the same way. Just as the sun can appear to be centered more on the northern or southern part of the Earth, to appear higher or lower in the sky over more or less hours each day, the position of the moon changes as well, and much more quickly. The place on the horizon where the moon rises on a particular day or night swings quickly from a maximum point north of east to a maximum point south of east, and back again over the course of about a month. The position changes more rapidly toward the mid-swing and slows down at either maximum before reversing. Although the moon can rise or set at any point on the horizon within its monthly range from north to south, it is difficult to observe it at any specific position on the horizon, except during the slowing at maximums. These slowing and stopping events for the sun are called solstices, from the Latin for sun and stand still, and the corresponding monthly positions for the moon can be referred to as lunistices, or more commonly, as lunar standstills. There is a northern standstill when the moon is rising and setting at a maximum point towards the north, and a southern standstill when it is rising and setting towards the south. Over the course of a year, the phase of the moon during which the maximums are reached changes in turn due to the changing relative positions of the sun, moon, and earth. As an example, the full moon is always opposite the sun, so when the sun is nearing its northernmost position, a full moon occurring around that time will be positioned far to the south, but the exact timing of the sun at solstice, a monthly lunar standstill, and a specific phase of the moon will not always match up. The tilt of the Earth has been decreasing over the last few thousand years, so that today the maximum positions are slightly less extreme than in the past. Besides this small change, the maximum positions of the sun on the horizon repeat from year to year. If the same pattern is tracked for the moon over a few months, the pattern may also seem to repeat, but if tracked over several years, the maximum positions for the moon will eventually be more extreme than the solstice positions of the sun. Many ancient cultures marked the yearly range of the sun at solstices, and evidence exists that some tracked the standstill patterns of the moon. When the monthly maximum standstill positions of the moon to the north and south reach a maximum extreme, this is called a major lunar standstill. Although there is an exact maximum position of the moon at one point in time during a major lunar standstill, the extreme positions change very little for about a year on either side of the exact maximum, so the moon at one phase or another will reach the most northerly and southerly maximums once each month. To distinguish the exact positions, one extreme can be termed the northern major lunar standstill, and the other the southern major lunar standstill. After a few more years pass, the maximum positions of the moon each month will be noticeably less extreme until they reach the same range as the sun at solstice, and then continue to decrease further over the years until the monthly maximum standstill positions of the moon reach a minimum range. At this point, the monthly swings from north to south will be less than the range of the sun at solstices, and this is called a minor lunar standstill. To define the rising and setting positions at this point, we distinguish a southern minor lunar standstill and a northern minor lunar standstill. The maximums will continue to increase again all the way back to the most extreme positions at the next major lunar standstill over a cycle of 18.6 years from one major lunar standstill to the next. The minor lunar standstill occurs halfway through the cycle at around 9.3 years, and about halfway between a minor lunar standstill and a major lunar standstill, the maximum rising points of the moon each month will match those the sun reaches each year at the solstices. These further divisions have not received much attention as they overlap with the same positions as the sun at solstices, but given that those positions were of importance to some ancient observers, when the moon reached the same positions, they would likely have at least taken some notice. These points in the cycle could be called equalized lunar standstills, one with maximum positions increasing from minor lunar standstill towards major lunar standstill, and another with positions decreasing from major lunar standstill back to minor lunar standstill. Northern equalized lunar standstill and southern equalized lunar standstill can be used to distinguish the range of the monthly swing, as with other points in the cycle. The reason the extreme positions of the moon are constantly changing relate to the plane in which the moon orbits the Earth. Although this plane is very similar to the plane in which the Earth orbits the Sun at a tilt of 23.4 degrees, the moon orbits the Earth in a plane that is tilted a further 5.1 degrees, and this orbit precesses so that the high point and the low point of the orbit change their orientation in space, taking 18.6 years to come back to the same orientation. When the high point of the moon's orbital plane matches up with the orientation of the Earth's tilt relative to the plane in which it orbits the Sun, the extra tilt of the moon's orbit is added to the tilt of the Earth's orbit, allowing the moon to reach more extreme positions toward the northern or southern part of the Earth relative to the equator, and as a result it can appear higher or lower in the sky and reach more extreme positions on the horizon each month while this orientation lasts. As the cycle continues, and the orientation of the moon's orbit precesses towards the opposite orientation, it passes through a point where the effect is cancelled, so that the monthly maximum positions of the moon are equal to the yearly maximum positions of the sun. Finally, the high and low points of the lunar orbit reach an orientation where they are positioned opposite the maximum and minimum points defined by the tilt of the Earth, which limits the monthly range of the moon to a minimum to produce the minor lunar standstill. The orbit then precesses back through the middle ranges until arriving again at the position to produce the extremes of a major lunar standstill. The 2 points where the orbit of the moon intersects with the orbital plane of the Earth relative to the Sun are called lunar nodes. At all other points in the lunar orbit, the moon is above or below the plane in which the Earth orbits the sun. This is the reason a full moon doesn't always enter Earth's shadow, as it will during a lunar eclipse, and the new moon doesn't always block the sun for those directly in the path of its small shadow, as occurs during a solar eclipse. The relative positions of the sun, Earth, and the moon at one of the two nodes line up twice each year, separated by about 6 months, to produce the conditions for at least a few partial or total solar and lunar eclipses to occur for those portions of the Earth positioned to observe them. As the 18.6-year cycle progresses, the positions of the nodes change so that the 2 times of year during which eclipses can occur shift through different times of the year. Because of the relationship between the lunar orbit and the tilt of the Earth, eclipses occur near equinoxes during both major and minor lunar standstills, although in opposite nodes. During an equalized lunar standstill, eclipses occur near solstices. At the equator, the moon rises at an angle that is more perpendicular to the horizon, and the angle between where it rises at maximum positions is not very wide. Towards the equator, the moon can also pass directly overhead as it goes between the northern and southern maximums. The latitudes at which this can happen are further north and south than those where the sun can do the same. The moon rises at sharper angles relative to the horizon the further north or south a location is positioned on the Earth. In the northern hemisphere, the moon angles to the south, and in the southern hemisphere, it angles to the north. The change in moonrise and moonset positions on the horizon become much more extreme. Beyond certain northern or southern latitudes, the extremes reach a point where at one maximum, the moon never comes over the horizon at all, and at the other, it never sets, instead tracing a great circle around the sky closer to the horizon or higher as it crosses the meridian, but always visible. How ancient cultures understood and related to the patterns of the moon in the sky and on the horizon are a part of archaeoastronomy, where there is still much work to be done. In modern times, we often think very little about the more apparent patterns of the moon in our everyday lives, and very few take notice of the more complex, long-term observations. Even without a full understanding of the underlying science and physics of these patterns, becoming aware of the observable physical realities of the sky as seen from the surface of the Earth can help us to gain an appreciation for the experience of these phenomena for ourselves.